Hello, in this video we are going to talk about representation of simple harmonic motion for displacement, velocity and acceleration, which is mainly we are going to derive when we said in the previous video a equals to minus omega squared x. That's where we are going to see where it came from. So to start with, if you remember that we said before x is equal to r cosine theta and theta is equal to omega t. Just as a matter of notation, instead of r, we are going to use a for amplitude of r. We will use a, which is the amplitude. Now, from this one, so x will be equal a cosine theta, and theta is still omega t. Now, some books instead of a they use x0. So if I replace theta by omega t, we'll get that x equals to a cosine omega t. Now, sometimes we may not start exactly at cosine, we may have some phase changes. So x equals a cosine of omega t plus phi. Or if you want to use sine, that would be fine. Again, you can say or x equals to a sine omega t plus phi, but mostly in AP mechanics we use the cosine. Now, if I want to find the velocity, we know that v equals to dx by dt. So we need to do the derivative. So which v equals to d by dt of a cosine omega t plus phi. And remember that the derivative of cosine is minus sine. So v will be equal to minus a omega sine omega t plus phi. If you remember, we said that velocity is going to be in the opposite direction of the displacement, which is we have the minus sign. Now, to get a, it will be equal to dv by dt, which is d by dt of minus a omega sine omega t plus phi. Now, the derivative of sine is cosine. So we will get a equals minus a omega squared cosine of omega t plus phi. Now look at this one. If I take a equals, put omega squared minus omega squared, and then a cosine omega t plus phi. This is the x, right? This is when we defined x of t. So from here, we can see that a will be equal to minus omega squared x that we used in the previous video. Now, if we want to find the maximum, the magnitude of the max of each value. So for magnitudes, x, its magnitude will be equal to a. The velocity v, its magnitude will be a omega, and a, its magnitude will be a omega squared. Again, as magnitudes. As real values, x and a, they will be in opposite directions. One will be plus, one will be minus. The second thing that we'll talk about is resonance. Now, to define resonance occurs when the frequency that we calculated before matches the natural frequency. Each material has its own natural frequency. In that case, this will lead to large oscillations, or you can say amplitudes. Now, what causes resonance? We must have an external force. So in the presence of sinusoidal, which means like they have like a sine function or cosine function, sinusoidal forces, a system may exhibit or have BN exhibit resonance. So the condition is we need to have an external force, and that force will create a frequency that matches the natural frequency, and that's when resonance occurs. Now, uh, if a simple note that some students they may have issues with it. If we change the amplitude, changing the amplitude, which we call that A, or you can call it X or R, A or X or R, whichever you want, does not affect the period of oscillation. So changing, it's just you are going to change the magnitude, but the period does not change. And same thing, if the period changes, if the period changes, then the amplitude will not be affected. So they are not related. So we can say that T and A amplitude are not related. Changing one will not cause any issues to or changes in the other. That's it for 7.1.